Austin. We know.
What did you say?
All right, here we go. August 14th, 2017, Eigengraph system of equations. Are we ready? You're crooked. We are live. We are here. We are on the air. Is everybody ready? Oh, my sweet potatoes.
It does, dude. You ever watched one?
No, I never watched it.
That's why you did well in class. Alright, so what we're going to do is we're going to fill in our first part. We're going to do some examples of what the solutions look like, and then we're going to practice graphing. Is everybody ready?
Yes, ma'am.
Alright, so a system of equations. Remember we did this last year. And what did we say a system of equations was? Is it one equation?
No.
It's two or more, right? So two or more equations is a group of two or more equations what? Starts with a C. C-O. C-O-O. Coordinates. Take a point.
I knew it.
I'll just say something.
So remember, when I give your team a point, you circle +1. If I take away, what do you circle? -1. Is everybody ready? Does anybody have any questions so far?
No.
Are we sure? Oh. Okay, so we're going to talk about the different types of solutions and what the graphs look like with solutions. Now that Manny is not stabbing himself in the face. So what does no solution look like? Do the lines touch if it's no solution?
No.
So what does that look like?
They're both like, shoot.
They don't
They're right next to each other.
So show me with your arms what that looks like.
This.
Like this? So what word is that?
Parallel.
Parallel. And if they're parallel, what do they have in common?
No solution. They're both the same.
Same what?
Line. Direction. Corner.
Starts with an S.
No solution.
No. If you have parallel lines, they have the same what?
Size.
What is this called? No. The way my line tilts, what's that called, y'all?
Sideways. Slope.
Slope.
Oh.
Take a point, Ravenclaw.
She said slope.
Who said slope?
I said it first,
Michaela,
though.
take a point as well. Don't lie. Alright, so let's draw two lines that are parallel to each other. That's one. And here's the second. Do those lines cross? No. Also, did you guys read over here? It says if both lines have the same slope and different y-intercepts, they are parallel.
No, I just.
It told us. Crazy that we should read the handouts, right? Man, oh man. And isn't there a highlighter beside that? So do you think we should maybe highlight this or like underline it? Hey, we're not whining already. It's the 4th day of school. You will lose points. Get it together. So let's go down the page. What would it look like if it was one solution? Show me with your arms what two lines would look like. Like that? Could it also look like this? Could it look like this? Could it look like this? Could it look... Well, that's all I got. Could look like that. So let's draw one going this way. Now, does it have to cross for it to be one solution? And it could cross anywhere, correct? Look at that. And it crosses right there. And that is our solution. Solution. Now, what would... Pardon? Oh, I need to pause. Remember, there are markers in the third drawer if you need markers.
Only if you want
Right, that's why I said if, correct?
to.
It's not. He's been in this class before. He just needs attention. D'Angelo. He's not used to sitting this far away from me.
Oh yeah, where's my seat? Must have moved it.
I did. Are we ready?
Yes.
What does infinite solutions look like?
A lot.
It has more things.
It has more than one, right?
Yes.
Does it have two?
Yes.
Does it have three?
Yes.
Does it have four? Does it have five? So what would that look like?
A lot.
A bunch of lines.
A bunch of lines?
Which
But how would two lines look like if they have infinite solution? What would it look like? Show me with your arms what you think it would look like. Like this, right? Are my arms on top of each other? Infinite solutions. Like, I can't make it do that. Like this, right? Infinite solutions. So, let's draw this line. And then I'm going to draw a blue line on top of it.
Whoa.
Now, it also says that in our bottom down here. It says if they have the same slope and the same intercept, they are collinear. Collinear is a fancy new word. What does the word linear mean?
Straight. A line.
A line, right? And what do you think collinear means?
Cooperative lines.
It's just.
A line
It's
that
just
doesn't-
one, right? They're on the same line. So collinear means the same line. So let's write that. It's a fancy word meaning same line. So if they have the same slope and the same intercept, they are collinear. They make the same line. Now, can somebody give me another example of one solution? So we have no, where they are parallel. Infinite, where it's one line. One solution looks like this. What else could I draw?
One line.
For one solution?
No, and
Bring it up.
oh, and then it goes up and down.
And then I could do one like this. But didn't we say it could be two or more?
Yeah.
So where would that third line have to cross
Up top.
for it to have one solution? Would that third line also have to cross right here?
Yeah.
It would. Look at that. And remember, our system is two or more. So we have three lines. They all cross at one point.
You stayed here with the person.
I made a face at Manny. Are we ready?
Hey.
Are we ready to practice? Are we super excited?
No.
Who remembers the main... I like that we were consistent on our no, that we're not super excited.
I was.
Lazy bums. Who remembers the way we learned several ways how to graph. What's one way you remember?
Graphic.
No. Graphing using what form? Slope-intercept form? And what's slope-intercept form?
Y equals
Y equals mx plus b. Awesome. Alright, what's another way that we learned how to graph?
We did y and z plus y1 got by x.
No, that's finding the slope.
Y equals.
No, that's slope.
And it,
So we did slope-intercept form, that was one way, right? And that's y equals mx plus b. We also graphed two other ways. There was another way. It's the first way. Starts with an S and a T. S and a T.
look it up.
So,
Standard.
Standard form! Take a point.
I was gonna say that.
It's also right here.
Oh.
I was like hoping someone would look at their notes, but you were all just looking around the room hoping that the answer was there. So standard form, remember we found our x and y intercepts. So what we're going to do is we're going to call this 1, 2, 3, and 4. Now the last way we learned how to graph was point slope form. Y minus y1 equals m times x minus x1. Standard form, slope intercept form, point slope form. So what we're going to do is we're going to graph all 4 ways, and then we're going to talk about the advantages of each way, the disadvantages of each way. So since we don't have enough room in this little bitty square to do number 1 together, I want us to turn to the back.
Can I do it on this?
And we're going to need to all turn to the back. We're going to call it 2C, and we're going to write number 1. So it gives us our system in standard form. 5x minus 2y equals 8. And the other equation is x plus 2y equals 4. So to find our intercepts, remember we have x and y intercepts. Do you guys remember that? Kind of. You can tell me kind of. It's okay to say kind of. So our x-intercept means it crosses the x-axis. Okay, so we're going to start with this one up here. And we're going to look for our x-intercept. And remember, if it crosses the x-axis, that means that y equals 0. Does anybody remember us doing this? We did it for like 2 weeks.
Oh, yeah.
So we take y, we take 0, and we plug it in right here. So we write 5x minus 2. What did we say y equals? 0 equals 8. Does anybody remember us doing this? Maybe vaguely. I was there. I even have my notebook still. What's 2 times 0? So that cancels. And we're left with 5x equals 8. How do we find what x is? Divide by what?
5.
Divide by 5. So x is 8/5. What is 8 divided by 5?
35.
It is not 35.
1.6.
1.6 repeating?
No. Just 1.6.
Just 1.6? Allie, do I need to angle it or do I need to zoom in? Angle your desk or zoom in?
I might have to.
Okay, that's cool. Does anybody have any questions on what we did?
No.
So we looked for our x-intercept because this was standard form and it told us to graph by intercepts. If you don't believe me, look back at the previous page. To find our x-intercept, we let y equal 0. So we plugged in 0 right here. Two times 0 is 0. Then we divide it by 5. 8 divided by 5 gave us 1.6. Jarek, will you please put your phone away? Thank you. Away. Thank you so much. Okay. Could you take your headphone out? Could you take your headphone out? Thanks. Alright. Good talk. Okay, now let's do our y-intercept. So for our y-intercept, what's going to equal 0? If our x-intercept, we let y equal 0, what are we going to do over here?
0.
What equals 0?
Oh,
X equals 0. It's the opposite. I'm going to plug it in for x, yeah. I'm going to do the exact same thing, but I'm going to plug this in for x. So I'm going to say, I'm going to click my pen. 5 times 0 minus 2y equals 8. Does everybody see what it did? Alright, what's 5 times 0? And so we have negative 2y equals 8. Why do I keep that negative in front of the 2? Because it's negative, right? It's that minus, so that makes it negative. Awesome. Now what do I do? Is it slowly coming back to anybody? Negativo cuatro? See? Alright, now, I want you to do the same thing over here. I want you to do the same thing, but for x plus 2y equals 4. I want you to find the x-intercept and y-intercept. Talk to your group. Figure out what you need to do. Make your two columns. Write that your x-intercept. What does y equal when we're looking for our x-intercept? 0. When we're looking for our y-intercept, what does x equal? Alright, plug it in. Go. Let's do this. We're doing it for this problem. Do I allow you to talk to each other?
Yes.
As long as it's about math.
I'm done.
Check with your table.
I'm not done.
We'll give them just a second. Maybe like take a breath or something.
Yeah.
Oh, I could pause this so we're not just...
What time does sea lunch go?